So now this shows how training progresses of a generator. So let's say this wobbly dotted thing that you see, this is the output of the discriminator. Okay, and this white is your true data distribution, and this is the output of your generator. So initially the distribution given to us by the generator and the data distribution don't match, and the discriminator is essentially outputting random numbers. After training it a little bit, what happens is, the discriminator quickly learns that within the data distribution, I have to output high. And then when I go from the data distribution to the to the generated distribution, I have to output low, right? So this is what you see, that there is this function. And then as training further progresses, the generated distribution and the data distribution, they come closer to each other. And the discriminator, as long as it's in the real, it outputs high. As soon as it is in the generated, it outputs low. And then finally, once the training has converged, the data distribution and the generated distribution, they completely overlap each other, and the discriminator is completely confused. It now outputs 0.5, right? It doesn't have the high and the low. And this is when you stop the training and you throw away the discriminator, because you only need the generator. And to the generator, you can give your noise vector, and based on the noise, it will also give you the different outputs. So this is the data and this is the output. And another thing one thing to kind of think about is, like, why do we call it implicit and not explicit, right? Because the generator never gets to see data directly. The data set that we have here, only the generator gets to see it. We feed it only into the discriminator gets to see it. We only feed it into the discriminator. The generator only gets to see it through the gradients of the discriminator, through the weights that are learned in the discriminator. So this is why we call it an implicit model. Also, another thing to think about is, why is training this generator difficult? It is because it's a very sparse gradient. The information that we are sending back is a very low level information, right? It's just saying yes or no. Is it a real image or is it not a real image? It's like telling me we want to write a story, and every time I give you a sentence, you just want to say yes or no, right? So it is a very faint signal. It's a very sparse signal. It's a very, let's say, not a very dense signal. And this is why training it is hard. And this is why we use special activation functions, and more on that in the next video, where we talk about actually coding it up.